able to know the 5-number summary quickly and easily. As always, least to greatest. Laura, 1,000 points right there. And let's do this.
I found him. What's he doing? I don't know.
The 5-number summary is the following values.
He's talking to someone.
From least to greatest, min, Q1, median, Q3, and the max. Nice answers. If you put the 5-number summary in the chat, you get 1,000 points. Keep these answers coming.
What is it? What happened?
Oh my gosh. Stranger Things. Who's in the chat? I feel like I gotta readjust. I'm gonna do a quick readjustment right here. I feel like the green screen. Because I did it a little while ago. Let me go. I'm gonna see behind the scenes. Hey Noel, I'm trying to find my camera green screened on here. I feel like I have to adjust the filters. And then we're gonna get started. Camera green screen, it should be this. I think it's better. I think it's better. I need like someone who, I've done this for a long time. I need someone who does it a lot, and like, oh, I do this a lot. I already do. It's because I'm in a room that the light changes, so then I wear a green every once in a while, or a yellow that, you never know. Anyways, we can start doing some analytics. The in-person office hours today should never eat. Oh my gosh, now you can hear me. Never eat stuff with almonds. Are you trying to make it no, I'm trying to make it so the green screen, like the effect, like you shouldn't be able to see like green on my shoulders, or I shouldn't be disappearing partially. All different things. And it's because today's really dim outside, and so you have lights in your studio that make it so everything looks all nice and pretty right here. I'm going with lights. And so then do this. It's all the lighting. You have to make everything like exactly the same, even lighting. Oh, thank you. Yeah, it's a tough task to make everything exactly right. I'm gonna send out an announcement on office hours, and they'll get started. What questions do you have? I might even release, we might release test grades. I think we can. So let me say office hours only online today. Today I am having only online office hours. Click to join. There we go. After whoops. Afternoon office hours. Email or Discord this afternoon if you have questions. Okay, there we go. I'm gonna send out one. Office hours only online. Office hours only online. We could do some chapter 7 homework too. Office hours only online. There we go. It says click to join external link. Let's do it. Let's release those grades. Let's release the grades. We need more music. Don't worry, Noel. It's all right. I think people did pretty well. We'll look at the average again here in a second. But people did pretty well. It's a tougher exam. So don't worry so much. Remember, keep working hard. And hey, Bailey, good to see you there. Ask questions if you got it. We're going to release the exam grades coming up right here. So with that, should we do some chapter 7? What should we do to start? When you get a chance, I was late yesterday, office hours, but I wanted to watch and I'm a little confused about the interpretation of jump. Yeah, we could do that. We could do interpreting. We could do interpreting. We could do data analytics. It's your call, your time right here to do whatever you think. And random messages now. How about we do that? We start with some interpretations. We'll be releasing grades. I think the coordinator said we can release them. Let's go over here and check out some interpretations. We're opening Jump 17. I like the Diamond data set. Or do we have Survey 10? Survey 22? If you have questions, when you get a chance, I need help with the last analytics set. Yeah, exactly. Are you thinking the... Yeah, we could do that. Reviewing. Let's go check that out. Is it pivot tables, pivot charts? And then we'll do some regression. Sat to 1, pivot tables and charts. Let's go look at some pivot tables and pivot charts. Okay, slow me down or let me know if you have questions. When it comes to pivot tables and pivot charts can be used to analyze quantitative or categorical data. We really don't use identifiers. We should be releasing them shortly here, Alicia. Good question. I'm probably going to release mine when classes start today, so stay tuned for that. Let's go right here and click Control A and go to Insert and Pivot Table. Now, you need to make sure you have Excel downloaded to your computer to have the Insert Pivot Table button right here. Insert Pivot Table. Then we're going to click OK. So let me know if you don't get to these steps right here, but you should see the pivot table options now on your screen. So once again, we'll close out this sheet right here, and you want to have your data open in Excel. I don't think the software is exactly working with your computer. Which kind of computer do you have? Make sure you've downloaded this from UT. So you might need to go to OIT, might need to swing by in-person office hours, but you want to have Jump downloaded to your computer. This isn't Jump, but this is Excel. You want to have Jump and Excel downloaded for the class. Jump and Excel are the two softwares we use. We'll be using Jump more a little bit later, but have Excel downloaded, which you can get to by going to Outlook on UT and going to download software right here, download Microsoft apps. So make sure you have Excel downloaded to your computer. And then with Excel downloaded, you can have it. Let me get that pulled up. You can help. Yeah, sure. Awesome. Here we'll hop over to talking about how to interpret regression. And literally, we are going to be seeing test questions right here. Does anyone know the 3 quantities you will have to interpret for regression on the next test? Does anyone know the 3 quantities? I'm going to see if it pulls up. Yes, it did pull it up. The 3 quantities you will have to interpret for regression on the next test. The 3 quantities you will have to interpret for the next test. The 3 different quantities. Might even save this. If you watch yesterday's office hours, you saw some of them and we're seeing them on the screen now. The slope is one of them right there. You can see the slope, the intercept, and the R-squared. So write down these interpretations. Write them down. You've got the intercept, the slope, and also the R-squared. The intercept, the slope, and the R-squared. You want to think about what these quantities are. The intercept is going to be right here. The intercept is when x is equal to 0, the value of y. The slope is for each 1 unit increase in x, we expect y to increase by b1. The intercept is notated as b sub 0. And then the r squared is basically how tight the points are to a certain degree around the line, because it's found by using r. So r squared is calculated by literally taking r and squaring it. Morning, Braden. Good to see you there. So r squared is literally correlation squared, which you can see right here. It's r squared. So we have price of diamond and carat. Now notice this. Let's go look at the relationship of this data. And let's pull up that price and carat data. So here we go to diamond data set. Open the diamond data set. And that's the Pokemon data set. Here we are. And let's go and do the following really quickly. Let's go to multivariate method, and do price and carat. Once again, we're just seeing the output. And look right here. Here is the correlation. So how in the world would we get r squared? Tell me the formula for r squared. Like if you had to find r squared from this, how would you find r squared? We're going to do does the price, because it's explained by carat. How would you get r squared? So once again, you're seeing how to get r squared here. So there's the value of r squared. How would you get r squared from this? Remember, it's r squared. So what would you do to find r squared? What would you do to find r squared? So correlation is the value of r, and then this is r squared. So what would you do? So this is r, and this is r squared. Yeah, Alicia, you got it. Yep. In square, so it's not really price. So good answers. This just stands for what this means in this matrix right now. This is a correlation matrix, chapter 6. When you go to price and carat, they have a correlation of this right here. That is the correlation of price and carat. So this is the value of r for the correlation of price and carat. And all you do to get r squared is take r and square it. And now we want to square it. There we go. And you see that's 83 usually times r squared by 100, 83.6, and there might be extra decimals we didn't square. But here's where people get tricked. Get ready. I'm going to show you where we have a test question and people get it wrong. So write this down too. Let me see the relationship between speed, and I'm trying to think of one that might work for this. Speed explaining. No. I'm looking for a very specific kind of relationship. How about, I'll just cheat. How can I define R if it's located in the same area? So when you see a correlation matrix, I might have to look at different data here. I'm going to grab this. So R, what does R mean? Let's start with what does R mean? What is the value of R? Like, what does it mean if we find R? What does that mean? So I go here and I say, let me find the value of R between height and weight. What is that value? What does this value mean? That is the what between height and weight. So this value right here, you see it says correlations. So it says correlations right there. This is a correlation matrix. What does this value mean right there? So that is the what? What does that value mean? What does that value mean right there? Oops. What is that value? How would you explain that to somebody? Like, what is that value? We have to know what we're looking at. It is a relationship. Yeah, it's the relationship between what? It's the relationship between what? It's the relationship between what? And what of the relationship? It's the relationship between height and weight. It's the relationship between height and weight, and it's their what? It's the value of their what? It's the relationship between height and weight, and it's the value of their Reptar. Good to see you there. It's the relationship between height and weight, and it's the value of their what? Not their average, it's their correlation. And our correlation is a value that ranges from -1 to 1, so there is a weak positive correlation between this. Now there's a huge outlier over here, and watch what happens. We're going to hit this. If I remove this outlier, what would happen to the correlation? So if I remove that outlier down there, what would happen to the correlation with that huge outlier removed? The correlation would get much wider. If I remove that huge outlier down there, what would happen to the correlation? It would get tighter and make it stronger. Notice it got stronger and tighter. Does that make sense? Closer to 1. So that value, and you just saw it happen, and we can do this, row unhide. So hide, unhide, clear row states I'm looking for. Clear row states, there is the, it gets tighter, right? Because that point is pulling it outward. So when you highlight the point and go to rows, hide and exclude, the correlation got stronger, closer to 1. Exactly what we should know. So now we have a stronger correlation, and you can see it because the points are tighter around a linear relationship. Correlation only measures linear strength. And now what is the value of R squared for this? So if I run the R squared, what is the value of R squared? So R squared, how would we find R squared for this? These are really good questions. We're already doing chapter 7 right now. This is chapter 6. This is chapter 7. It's basically an extension of chapter 6. How are we going to find R squared? Between what is the percent of variation in y explained by the variation in x when it goes to height and weight, which is R squared. So how would we, see if you can solve for R squared right now. How do we get R squared? Well, that's R. Correlation is the value R. Like that's what it means. You'd write R equals this. So how do you get R squared? Yeah, that's it, Brayden. Yeah. Then you go ahead and solve that. There's the value of R squared. That's R squared right there. We can double check it. You literally get, you see how it says R squared right there? It says R squared. And then you just take 0.6463 times it by itself. And there you go, and there's decimals, like, since there's more decimals probably behind that are rounded, it doesn't round perfectly, but 0.4177. So then on the test, you have to write an interpretation for that. So I'm going to take this output right here, and we are going to interpret these values. So we are predicting somebody's height, and we are using their what to predict their height. We are predicting somebody's what, and we are using their what to predict height. So this is the interpretation part I was talking about earlier. Predicting using weight, and Noel got a great job, Noel, right there. We're using, and Noel has it. That's what we are using. And I wish I could line this up perfectly. I guess if I delete the top of the graphic, it might line up. Crop this. Almost. Let me go wrap text behind. I might be able to just cheat. Yep, there's no. One last try. I think it's, might have to erase a lot of the highlighting. And 2 seconds, we're gonna get this out around here. Okay. And then there we go. And let me move this just slightly. Good, it's moving. And oh man, I don't think I can get it lined up. Well, no, I make it bigger in the lineup. There we go. Okay. Yeah, there we go. That's pretty lined up, almost. Okay. How do we interpret the R squared? How do we interpret the R squared? How do we interpret the R squared? Does anyone know how to interpret? Actually, that is pretty much lined up now. How do we interpret the R squared? Does anyone know how to interpret the R squared? Try using what I have on here to interpret the R squared. How do you interpret the R squared? You want to go down here to the bottom of the screen, use this. Let's give it a shot. If you write it down, you'll remember it more than me saying it. So you have to think what your y variable is. I'm going to highlight a little bit better here. Whoops. That's pen. All you're doing is plugging in values. So all you're doing is plugging in values. There, that's good. So you see where down here at the bottom it says blank percent times 100 of the variation in y is explained by the variation in x. And they've got y highlighted up here and x highlighted. Well, that is r squared. That is the value of r squared. But on the test, that might get 1 out of 4 points. That is numerically the value of r squared. And when the test says interpret, you have to write the full sentence. That's where a lot of people make mistakes. And the people who don't come to class, they say, I don't know what to write. What do you want me to write right here? I have no, you have r squared, there's the value. Don't worry. That is why I have everyone try to write it out. And you'll see today in class, I'll be like, write it out. Write it out. Write the full thing out. So what do we have? What do you think? Just the full sentence. If you're watching this in the future, try writing it out. Because if you don't write it out, you won't remember. So you just have to plug in the values. You see where this is blank? Plug it in right there. You see where this is blank? Plug it in right there. Now, we don't write predicted height, just write height because it's the y variable of interest, but we are predicting height. And then x, just plug in x. And you're like, oh, that's all we do? Once you do, you're like, that's it? So if you know blank percent of the variation y is explained by the variation in x, what do we write? Give it a shot. Who's got it? I know someone's got it here. Blank percent of the variation in y is explained by the variation in x. So you want to take r squared times it by 100. Give it a moment more, see what people say. Blank percent of the variation in y is explained by the variation in x. But you don't want blanks. You don't want x and y in there without the values of y and x, what they are in the equation. So you see where the color coding is? You just go right here, plug in that value times by 100. See where this is right here? Plug in that value, but not predicted, just say height. Plug it in right there. You see where this is? Plug it in right there, and you're good to go. Give it another 10, 15 seconds. Try typing it out. Don't worry about being wrong, because you will type it out on the test too. So on the test, you'll have to type this out also. Blank percent of the variation y is explained by the variation x. If you have a note card interpreting r squared, blank percent of the variation y is explained by the variation in x. Oh, who's got it? Someone give it a try. Don't worry about being wrong. Who's got it? Oh, I know someone's got it. No. Any answer, and I'll give away the answer. Give it a shot. Any answer, and I'll give away the answer. And then we have 2 more interpretations to do. 2 more. Any sort of answer. Who's got a shot at it? Close, close, close. So close. Noel, good try right there. So right here where the orange is, plug in the value and times by 100, 41.7. Do you see how I get 41.7? So what you do right there is you plug in the value of 41.7% of the variation in height is explained by the variation in weight. So if you look, and when you see right here, I think it might make more sense, is that we're taking the r squared value, timesing it by 100, and then we plug in the value of height right here, because height is the name of the y variable, and then we take the name of the x variable and plug it in right there. Does that make sense how I'm doing these plugins? So wherever you see highlighting, you want to make sure you plug in... Yeah. Once you see it, that's... Well, you won't multiply. You're gonna... It's a sentence like 41% of the variation in height is explained by the variation in weight. So you're explaining what it means. You're saying, well, what the r squared means is 41.7% of the variation in height, which is the y variable, you don't have to say that, is explained by the variation in x, which is the variable weight. Don't include the x and the y. We always want to give the context to data. As Braden said right there, like, oh, you're just plugging it in. So give this a try. You ready? We just did the r squared. Yeah, no, not the numbers. That's B1 and B0. Do you see the pink and the yellow highlighting up here, Braden? You see where I have, this is B0. B0 is this quantity right there, and I also have B0 written above it. B0 is the value 55, and B1 is the value 0.09. X is the name of the X variable. Y is the name of the Y variable. Like, once you start to see, you're like, oh, no, don't worry, more points. That's why I asked, just give it a try. If you get it right the first time, it's easy to remember, but then when you practice, it's like, get it down. So try the intercept. Now try to do it knowing how to use this. Notice the color coding. Try using the interpretations, and don't do predict. I shouldn't have wrote predicted right there. We are predicting it, but don't say predicted this. Just say height. We are predicting height. The variable name is height. So try doing the intercept right now. Try doing the intercept. The intercept visually can be seen right now. It's over here. There's where the intercept is at. And then think about what the intercept is showing you and what it means. Give it a shot. Don't worry about being wrong. Remember, plug in the values. Just take whatever's highlighted, plug in the value up top. When weight is 0, we expect, great job. Now, is that logical? When someone weighs 0 pounds, we expect them to be 55 inches tall? We might throw in some 55 inches right there because it's height in inches. And problem would probably say that's a little context. No. And so we'd say that. We would say this is not logical because you can't weigh 0 pounds. And notice the model is what we would say extrapolating to that. Great job, Reptar, right there. Does that? And so you probably, I'd throw in a little extra on that. That's probably, most graders might give you 4, 3.5, or 3. You're going to get most of the points with what you wrote there. But I'd add on the extra, like, this is illogical because someone can't weigh 0 pounds. Does that make sense? So that's why I have the, is this logical? You kind of ask yourself, you'd be like, when weight is equal to 0, we expect height to be 55 inches. Well, this is, and you could say 0 pounds. When weight is equal to 0 pounds, we expect height to be 55 inches, but this is not logical because you can't weigh 0 pounds. How about this one right here? How about slope? Think about slope is the 1 unit increase or decrease. So how would we interpret slope? And I'm gonna do a section called like possible test questions. We could do even chapter 7 homework, get that done. Get it done. How would we interpret slope? So slope is B1. For each 1 unit increase in x, whatever a 1 unit increase in x is, so you can also give that context. We expect y to increase or decrease, make sure based on value of the slope, which is positive here, so increase. We expect b1, which is the value of b1 right there on average. So give it a shot. Once again, the more you practice this, the more you get better for writing it for the test. And I'd write this down, interpretation of slope. For each 1 unit increase in weight, so for each additional pound, for each 1 unit increase in weight, we expect height to increase by 0.09 inches on average. I'll make sure to throw in a little bit of that context right there if you know it. So good answers right there. Great job. For each 1 unit increase in weight, so for each additional pound somebody has, we expect height to increase by 0.09 inches on average. And that kind of makes sense. Like, people who weigh more are generally taller, and doesn't mean you will be taller. Don't say will. You notice here the expect word is key, because it's not like if you gain weight, you will be taller. It's people who weigh more are expected to be taller. For each 1 unit difference in weight, we expect someone to be this much taller. Not that they will be, because some people might weigh more, and then some people might be taller, but shorter than them. So it's not a will, it's an expected. I do want to show, so we could try, watch this. We'll do one more set of interpretations. And how about, we could do this one. We did this one yesterday. Okay, what does the R squared of this one mean? So we're predicting price from caret. So you're looking over here at this one. So just practice. We're doing it faster now. Once again, you're going to do this on the test. This is, I think, 12 points of the test. You're literally doing 12% of the test right now. If you practice this, if you come back to this, you're like, I'm going to do this before the test. Blank percent of the variation y is explained by the variation x. So you have to, like, R squared interpretation. Blank percent of the variation y is explained by the variation in x. That's the way to remember. Yep, no, you got this. So do the R squared over here. You got this. Blank percent of the variation in y is explained by the variation in x. Take a look at it. Blank percent of the variation in y is explained by the variation in x. You got this. R squared, blank percent of the variation in y is explained by the variation in x. And it's explained by the variation in x. R squared is an amount of variation. It's based off of R. So what would be the R squared here? What would be the R squared? Give it a try. Reptar, you got this. I'm voting on Reptar this time. Blank percent of the variation in y is explained by the variation in x. Blank percent of the variation in y is explained by the variation in x. I'm literally teaching to the test. Blank percent of the variation in y is explained by the variation in x. The context of it over here. Just plug in. Oops, didn't want to do that. Where'd it go? Blank percent times that by 100 of the variation in y, wherever the y variable is right here, is explained by the variation in x. So what do we have? Give it a shot. So remember, just plug in the r squared times by 100. The y variable name right here, x variable name right there. Blank. So now I'm not highlighting for you like I did up top. 83% of the variation in, I'll reverse it right there. Reverse it. Good answers, Noel. Reverse the x and the y. Remember, it's blank and good work. Blank percent of the variation in y, which is the y variable of interest on the left side of the equation, is explained by the variation in x. So this is the x, and this is the y right here. So the y variable being price, so we can put the price back here, is explained by the variation in caret. Caret is explaining price because caret is the x variable that does the explaining. So when you say is explain, 83.6% of the variation in price is explained by the variation in caret. And if you annotated a decimal, I'd probably be like, it's all right. The x and the y flip-flop is more of an issue, but this is why we practice. Blank percent of the variation y is explained by the variation in x. How about this? Is the intercept logical, and what does the intercept mean? Here's the value of the intercept, which is b0. It's the first number. It's b0. It's not connected to x. And look at this. If you plug in x of 0, if caret is equal to 0, here's what the equation solves to. Let me show you that again. If caret were to be equal to 0, you'd plug in 0 caret, and then something times 0 is 0. So think about this. Think about what you've just done. Now, what does this mean? And look down here at the equation, and you can see it goes negative, or look at the graphic. What is the interpretation of the intercept? Exactly, it is illogical, because this says when x is equal to 0. What is x again? Try talking about it here. What is x again? When x is equal to 0, you can see x right there on the x-axis. We solved the equation for x equal to 0. When x is equal to 0, we expect y. So give me the full interpretation. When x is equal to 0, we expect y to be equal to b0. And b0 is the quantity of the intercept estimate down there in the output also. And we solved the equation right here to be that. I'm going to rewrite just a little bit while you try to write the equation. It was something like plus about 8,000 caret times caret. That is b1x. Oh, really? You're going to do that? Sure. Let's go into the next line over. I didn't want that. So what would be the interpretation? And then tell me why it doesn't make sense. When carets are equal to 0 for a diamond, we what? When the carets of a diamond are equal to 0, which we just wrote, we just do caret of diamond equals 0. When caret is equal to 0, we expect the price to be, which is not logical. You can't have negative price. Great job, Braden, right there. And you see it right there. It's not logical. You also can't have a 0 caret diamond and be like, you could give your fiance a 0 caret diamond and it just would be nothing. It doesn't exist. If it's no carats, there's no size to the diamond. So that's not logical. How about this? What does the slope mean? The slope would mean what? For each additional what of a diamond, we expect the what to do what by what. So for each additional what of the diamond, we expect the what to do what by this amount on average. And just look at it. Well, you can see the value of the slope over here. Don't let your wife find out it's 0 carats. Exactly. Oh, exactly. Like, this is 0 carat diamond. I give you a diamond, a 0 carat diamond. That's not going to fly. So for each additional what? So for each additional x, for each 1 unit increase in x, which can be said for each additional. So for each additional, which is for every 1 unit increase, for each additional x, for each 1 unit increase in x, we expect y to increase or decrease. We have to look at the positive or negative nature of the slope by b1. This is b1 right here. This is b1x. This is b1 next to x. So whatever's next to x is b1. So what would that be? For each 1 unit increase in x, which is the name of the x variable, we expect y, name of the y variable, to increase or decrease by b1 on average. I think the slope is connected to the x variable because it's the xy relationship. So how does that go? For each additional carat, we expect the price to increase. Nice job, Noel. You got it. That's exactly it. For each additional carat on a diamond, we expect the price to increase by $8,000. So what if the diamond's a half carat bigger? $4,000. Quarter carat? $2,000. For each additional 1 unit increase in carat, we expect the price to increase by $8,000 on average. Exactly. Or carat diamonds that have an additional carat, we'd expect to be $8,000 more. This is a lot for a carat. So I'll say I'll just buy a new TV. You can't watch. I guess you could look at the diamond a lot. Watch TV though. $8,000 TV. Pretty crazy TV. Like 8K 90-inch TV Sony OLED. So here is, let's do some test questions on this. I got the chart done in Excel, but I do not have the pivot chart button in my Excel. I'll have to figure out how to re-download. Let me know. Send me screenshots. You should have, when you do your pivot chart, pivot table, there should be, when you do the insert, and you throw some things in here. I'm just tossing things in. It's crazy. You should have under the pivot table analyze the pivot chart, and that will bring up, and I wouldn't make one that looks like this. I just kind of made it quickly. Under pivot table analyze, when you click inside of here, you should have it. Make sure you have Excel downloaded, and it should be there. Good job. Glad it makes more sense. We'll do some test questions right now, and Bailey, let me know. Let me check some more out. Thank you for being here, everybody. Let's show you some points. Remember, these points add up. Let's do regression test 2 questions. Okay. Here's one of my favorite questions that people get wrong. It's also on the Canvas content. You know what? Let's do Canvas content instead. Let's do that. Oregon today. Yes, we will have office hours next week. Canvas content regression. Okay, we're going to do Canvas content regression. Mo's like, what will people watch? If we do a Canvas content, people will do it. Yeah. Braden's already like, let's do the Canvas content. Okay, so let's go to assignments. Get Canvas content going right here. Okay. So we're going to learn some of the Canvas content by just doing it right here, learn some of the material. Here's the one I was thinking of, the exact question. So here's the problem we run into. And I have to make a graphic to show you this. So with this right here, let's look at the relationship. Do I have enough variables to do it? And sure, why not? Okay. Good, this one. Okay. What is the correlation here? So does everyone see here's r squared? So what is the correlation? That was the last one. Well, good question. Does anyone know what the correlation? This is r squared. Remember, r is correlation. So what is r? Does anyone know what the value of r is right now between these two variables? Between age and height, what is the value of r? See if you can solve it right now, and then you'll see why it relates to what we were asked. So this is r squared. How can I get r? You'd be like, well, it's obvious, right? What is the value of r? Try to get it, and don't worry if you get caught by the trick on this. What is the value of r between height and age? The correlation. What is the correlation between height and age? And we have r squared currently. So Noel, good answers. What did you do, Noel? What did you do? Because it's r squared, right? So you went here and you said, well, if that's r squared, square root it. Or that's what we would square root it. Does that make this? Don't worry about r squared adjusted. But do you see how if this is r squared, see what's r square? Like it's the correlation square, the square root of the correlation. Correlation is r. So if we have r square, what do we do to r square to get r? So let me repeat the question. What do we do to r square to get r? So r squared is the percent of variation y explained by the variation x. It's no longer correlation. R squared is not correlation. It's correlation squared. It's a different idea. It's like if I square your salary, that's not your salary anymore. It's your salary squared. It's a new idea. So what do you do to r squared to get r? Once again, the question is, what do you do to r squared to get r? What do you do to r squared to get r? What do you do to r squared to get r? There's r square. What do you do to r squared to get r? It's r square. So what would you get? How would you get r? Thoughts on that? It's r square. You want r. I'll draw it out. Let's draw it out. Right now you have r square. How would you get r? How could you make those equals? What could you do to r squared to get r? You have r square. How would you get r? Not divide by a half. Square root, right? Good answers, good answers. You square root it. But now I want you to look at this, and this is where you run into problems. What do you notice about this line? The line goes what? The line goes where? Look at the line right here. And great job, Reptar, everybody. What do you notice about the line? The line what? Goes down. It is kind of flattish. It does go down. I wish I found a stronger negative one. But the line goes down, right? So correlation must be negative. Does that make sense? So the answer to the question on how do you, if you know r squared, how do you get correlation? Is it A, B, C, or D? Which of these sounds like what I just walked you through? If you know r square, how would you get correlation, which is r? So just saying, if you know r square, how do you get r? The correlation is r. So if you know r square, how do you get correlation? So I kind of just walked through the steps of finding it. So the answer was, it was negative. Yes, that is correct, Noel, because you take the square root of it, and then you have to look at the direction to see if it's positive or negative. Because when you square root something, you don't get the negative. Because think about this. This right here squared is going to be the positive version. So when you square a negative, you get a positive and you lose the negative. Square rooting it, you have to look at the scatter plot to see if it's negative, and then you find out, oh, it's a negative correlation because the line goes down. But when you bring it to r square, when you square r, it becomes positive. R square is always a positive number. The percent of variation y explained by the variation x. It's a percent of variation, so it has to be a positive number between 0 and 1 times by 100 for barely 0.5%. Does that make sense? On r square is a percent of variation, and correlation is negative 1 to 1. So when you square correlation, you will always get a positive r square value. So when you go back to correlation, you have to check the direction to see if it was negative or positive correlation. Because correlation can be negative, r square is not negative, and it's not correlation. They're two different ideas. Find the predicted value of the regression equation. The regression equation is... Oh, we don't even have Mubot. Mubot hasn't been here this whole time. I'm going to hit the 2,000 point button. This whole time, Mubot's been sleeping on the job because I forgot to wake him up. The regression equation is y hat equals b0 plus b1x. How hard does this question look on a scale of 1 to 10? How hard does this question look on a scale of 1 to 10? Be honest. Don't worry. If you say 10, that's all right. If you say 1, that's all right. A 1, a 6. What do we need to do with this question right here? What do we need to do with this question? How are we going to solve it? If it says, find the predicted value, it's saying, find this. So what do we do? You got it. Plug in the values if you know. And you actually get the equation of the line on the test. On the test, we give you the equation y hat equals b0 plus b1x. So you just plug in here, predicted value of y equals, not going to go over myself, good, 11 plus, and then b1 is 1 times x is 8. And the answer is what? 19. You got it. There you go. And you get the equation of the line. So just make sure to plug in the values. You just have to know b0 is 11, which is the intercept. That is the value of the intercept, and then this is the value of the slope coefficient, and that's b1 and b0 respectively. Intercept, slope, value of x, value predicted y. So we'll be going over that today, and the value here is 19. If a residual is positive, what was larger? Residual is the formula actual minus predicted. The way to memorize this is residual wrap. So residual equals actual minus predicted. In notation, that is E equals y minus y hat, where the y hat comes from the y hat equals b0 plus b1x. But what are the only two answers to this A, B, C, or D? If residual equals actual minus predicted, then what are the only two answers? Rarely do we solve for x. That can be tricky questions. Good answers, Noel. What are your only two possible answers to this? If residual equals actual minus predicted, A and D. Those are the only, we've narrowed it down knowing that residuals are actual minus predicted. Because it says the residual right here is, which is going to be larger, the actual or predicted. And think if it has a positive value, would it be the A or the P was larger. If a residual has a positive value, you also get this equation right here, but we give it to you in the residual equals actual minus predicted. Predicted comes from the equation. Which of those would be larger if this value right here is a positive number? Would it be A or P, which is larger? I think math, you can plug in numbers. It'd be the first one, right? It'd be actual. And the way this looks visually is the dots are the actuals. So when you have dots, the dots are the actuals. And the line is a prediction. So the line gives the predictions. And if the residual is positive, then the points are above the predictions. If the residual is negative, then the points are below. And if a residual is 0, then the dots would be where? If a residual is 0, which thing? How do we get which thing? If a residual is 0, then the dots would be where? The one, oh, so we were saying the actual has to be larger. What Braden was saying was this one right here is the answer, because if you plug in numbers right here and you do like 20 minus 15 equals positive 5. So if a residual is positive, the first number was bigger, the actual. Does that make sense right there, Noel? And it would be that the dots are above the line. The residual is the distance to the line. And when a residual is positive, the dot, which is the actual, is higher than the line itself. So a positive residual, the dots are the exactly, Braden, you're seeing it. The dots are the actuals. So like if you go to one of our plots from earlier, does this point right here have a positive or negative residual? Does that point right there have a positive or negative residual? Does that point right there have a positive or negative residual? Does that purple point right there? Negative, exactly. And what it is, and this might help Noel to see this right here, this has a negative residual because it's where? This point right here that we've highlighted with the purple star has a negative residual, which this is its value of residual is E right here. We can even estimate its residual by saying like how much distance is this? That's about 10, negative 10, because it's below the line exactly. This is right here is its predicted value. There's not a dot there, that's its predicted value. And then down here is its actual value. And then an actual means its y value. That's its y value. Like it's the y means what we observe it to be. This is its predicted, and then this is its e, which is its residual. E is, I don't know why we did e for residual, but statisticians did that. So the formula for this would probably be something like that's about 73 predicted, so minus 73 and about 63. All I'm doing is tracing over here and making guesstimates of where it's at. Does that make sense what I'm doing for these values? And this is negative 10. So as in it's 10 below its prediction. So this value of negative 10, which is this value right here, is how far below the, oh, I did residual in, oh, no, I did wrong colors, sorry. The residual is, this is the actual. It's actually at 63. Its residual is negative 10, meaning it's 10 below. That's where I made a mistake. It's 10 below its prediction of 73. Does that color coding help right there to see it was predicted by the line to be 73? And residual equals actual minus predicted, also known as y. Oops, my gosh. Come on, Brian. Residual equals actual minus predicted. There we go. And I write P for predicted. That is technically y hat, as you can see up there. And then residual is E, but I write R for residual when I'm just doing it to memorize the formula. And then this right here. Is this making sense what a residual is? It's how far above or below the line is. So the R, and yeah, and that's not R for correlation. It's just a shorthand for wrap, because then you can memorize residual equals actual minus predicted. And the R is how far above or below, which is which is E in notation, how far above or below the line a point is. That's so this point right here has a residual close to what? That point right there has a residual very close to what? That point right there has a residual very close to what? We could even go to save residuals on this. Where's save residuals? Can I save residuals? 0. And you can also do plot residuals if you go down here. Oh, you can save residuals if you go here. Save residuals, and now we can go look at the data set. Which data set are we working with? Got a lot of data sets. Is this data set? There we go. And you can see the residual is very close to 0 for that person. So, and then you can see like a really negative residual. Like if you go to one that's really negative and they'll be very far below the line, like that one right there, we're highlighting. We'll delete those plots. There they are right there, -4 below. Exactly. If something's on the line, it's gonna, if they're right on the line, they're gonna have a residual close to 0. Like the residual for this person is very what? When I go look at them in the data set, the residual for that person right there, I'm trying to get so we can see them at the same time as the data. The residual for that person is going to be very what? You can see it over there. The residual for that person, there's their distance, and there's their residual right there. Not close to 1, very positive. The residual is how far above or below the line someone is. So that person is 8 units above the line. So I'm trying to get to where you can see the axis. If you look right here, that person down to the line is like 8 unit difference. So this 8.2 means they are 8.2 inches taller than they were predicted to be. This person right here has a very what residual? And you can kind of guesstimate it if you do this. You can go over like and do that, and you can say like, -7 or so. And let's highlight them again. I think -7-ish. Yeah, -7. How was I able to figure out -7? By like going to the line right here. So residuals, they can be positive or negative or 0. It's how far above or below the line the point is. The point is the actual, and then the line is the predicted. So I go right here to the line, and I kind of say, how far are they below? You see I'm looking at how many units this is. It starts at 65 and it goes to 58, so that's about 7 units, and they're 7 units below. So they are 7 inches shorter than they were predicted to be, because they were predicted to be this height, and then they're 7 inches shorter. Does that make sense? Really good review of residuals right now. So they're 7 inches shorter than they were predicted to be. This person is a tiny bit taller than they're predicted to be. So they're going to have a tiny positive residual, and there they are, 0.4. They're 0.4 inches taller than they were predicted to be. The line is the prediction. So all that to say, which of them is larger? The actual. Consider this jump output right here. This is just reading jump output, and you also get interpretations. 34, I think that's the right one. 34.4% of the variation. If you get this on the test, you are literally seeing blank percent of the variation in Y is explained by the variation in X. It says associated. I like to say explained by. I prefer to say that. B1 is going to be 2.43 because that's the value of the slope right here, the estimate of the slope, or I'll write this out. We're about to finish office hours, but make sure you know how to mark the notation on this to where if you get this, you'd go in here and put B0. Change color on that. B0 plus B1x, and that is Y hat. And this is also B0 right there, and that is also B1. So knowing your notation right there is going to be a huge help if you get a question like this, which literally you can go right here and choose the slope and choose the intercept, where the intercept is 156.5. And there it is. For each 1 unit increase in X, we expect Y to increase by B1 on average. Is the interpretation of A, B, C, or D. A, B, C, or D. And once again, you get a hint for the test. Almost, no, I should, am I frozen now? Uh-oh. Are we still streaming? Oh, wow, that was weird. Oh no, I froze. I didn't have my Red Bull. Which one of these? For each 1 unit increase in X, we expect Y to increase by B1 on average. I know, right? That was weird. Which one of these is it? A, B, C, or D? For each 1 unit increase in X, we expect Y to increase by B1 on average. That is the interpretation of the what? A, B, C, or D? Which one of these is it? A, B, C, or D? Residuals are how far above or below. And so make sure to write down these right here and put them on note cards. For each 1 unit increase in X, we expect Y to increase or decrease by B1 on average. Is the interpretation of the slope. So make sure to put those on note cards. For each 1 unit increase in x, we expect y to increase by b1, or expect y to increase or decrease by b1. And it could be decreased if it's negative, but that is the slope interpretation right there. So we should get a 10 out of 10. We might do one more. Is there? Oh yeah. Always class. I might, Thursday next week might be a little bit interesting. Correction. We already did this. Is there not many questions on this? Braden, Noel, did you get 100? Did anyone get 100? I'm flying through this right now. Oops. Predicted value. 29. What is, if correlation is equal to this, what is R squared? Yep. Maybe you got this one too. If correlation is equal to this, what is R squared? And how would you find it? If correlation is 0.5, how would you find R squared? So that is the value of R, and it says, what is R squared? So that is the value of R, and it says, what is R squared? Yeah, that's it. Because this is R, and you just square it to get R squared. So we can go right here and take R and square it, and it's just going to be 0.25, and there we go. There we go. Do one more version. Hopefully get some 10 out of 10s. Preview one more, see if we get different questions. For each 1 unit increase in x, we expect y to increase by b1 on average. Is the slope? Write these interpretations down, put them on note cards. When you find r from r squared, you need to square root it and look at the direction, because it could have been positive or negative. We're getting the same questions here. This is blank percent of the variation y is blank by the variation x. If you add together all the residuals, they will sum to 0. So if you have r squared, you can square root it to get r. Exactly. If you have r squared, you can square root it to get r, and you need to check their direction. If you have r, you can square it to get r squared. So when you're going from r squared to r, you need to check direction. So when you go this way right here, check direction. But if you're going and doing your r, turning it into r squared, so if you go right here and take this and square it to get r squared, then when you square r, you don't have to worry about the direction. Exactly. And then if you currently have correlation, you can square your correlation to get r squared. But if you go backwards and square root this, then you have to check the direction. Because when you square root a positive number, you don't know if the number that gave you it was negative. Like if you have negative 0.3 and you square that, you will get 0.09. The problem is if you don't know what r was and you square root these, now you might get 0.3 when you do it, but you have the plus or minus. And the way you know if it's plus or minus is by looking at the direction, because both positive 0.3 and negative 0.3 would give you 0.09 when squared. Does that make sense? So when you square root something, it's like plus or minus, and the way you know that's by checking the direction. So r can get you r squared by squaring it, and then when you square root r squared, make sure to check the direction, because we don't know if it's plus or minus. Reptar's got them. You got a new picture, Reptar, right? I swear you do. That's nice. Did you? Yeah, you did. Unless that's a new Reptar here. New picture. With that, we're going to have office hours in a little bit. Or not office hours, we're going to have class. See everyone soon. Bye for now. Bye. Woo. Where's my car? Oh, no. Where am I? Yeah. Bye, everybody. Woo! More time in class. You made it with Bing. Nice. I'll see everyone later. Bye. Class time soon.